Just imagine, you point the most powerful telescopes ever created by humanity at a point of total darkness, at absolute emptiness, there at the very beginning of time and space. The mission was this: capture the oldest and faintest light in the universe, the first whispers of creation. And that's exactly what NASA did with Hubble, and especially with the James Webb Space Telescope. The bet was to find baby galaxies, tiny ones, kind of chaotic, newborn. But what the universe sent back was something different. Something that, according to our science, simply shouldn't be there. And this discovery is making scientists wonder if the first page of the story of the cosmos might need to be rewritten. What they saw wasn't just what they were looking for, but a mystery that challenges the foundations of what we thought we knew about the universe. To get an idea of the magnitude of the discovery, first we need to understand what scientists expected to find. Our guide to the universe is the so-called Standard Model of Cosmology. It tells a story that begins 13.8 billion years ago with the Big Bang. Right at the beginning, the universe was a super hot and dense soup of particles. As it expanded and cooled, light finally managed to travel. But the universe entered a phase we call the Cosmic Dark Ages. It was a giant fog of hydrogen, no stars, no galaxies. Just darkness. It took hundreds of millions of years for gravity to start pulling together the first atoms. Small pockets of gas began clustering and forming the first stars. And these stars, in turn, came together to create the first galaxies. The theory, confirmed by decades of Hubble observations, was that this process was quite slow and gradual. Think of it like building a giant city starting with mud huts. The first galaxies should be exactly that: cosmic babies, small, irregular, and struggling to grow. The James Webb mission, with its superpower of seeing in infrared, was precisely to peak at this phase. It was made to see the cosmic dawn, the moment when the first light from stars and galaxies tore through this darkness. Astronomers were ready to confirm this story, to finally take the picture of these baby galaxies and complete our cosmic family album. They pointed Webb at a seemingly empty little piece of the sky and waited. And what they saw left everyone's jaws on the floor. The first images started arriving and, along with them, confusion. Hidden in the data, like almost invisible red dots, were objects that made no sense at all. To everyone's surprise, Webb found galaxies that already existed between 500 and 700 million years after the Big Bang, but that were already enormous, as massive as our Milky Way today. Joel Leja, an astrophysicist who participated in the study, summed up everyone's shock. We expected to only find small young galaxies, but we discovered galaxies as mature as ours, in what should be the dawn of the universe. These objects, which the researchers themselves nicknamed universe breakers, were, according to the current model, simply impossible. One of the candidate galaxies had a mass that could reach 100 billion times that of our Sun. The theory said there wasn't enough time for the universe to gather so much matter and create colossal structures so early. Ivo Labe, another researcher, made a perfect comparison. It's like finding a baby that weighs 220 pounds. It simply wasn't supposed to happen. And the problem wasn't just the size, it was the maturity. They weren't only giants, they already looked well-formed, some even with a compact disk, something we thought took billions of years to form. And on top of that, they shone much brighter than expected. More brightness means more stars, which suggests that star formation in the early universe was much faster and more explosive than any theory predicted. And it wasn't an isolated case. Several projects like GLASS and SEARS kept finding these anomalies, forcing astronomers to an uncomfortable conclusion. Either the calculations were wrong, or our understanding of how the universe formed was incomplete. From there, science went into full investigation mode. The fight was on, James Webb Telescope versus the Standard Model of Cosmology. Basically, 3 lines of investigation emerged to try to solve this puzzle. The first, and safest, was: are we measuring things wrong? Looking so far into the universe is extremely complicated. Maybe cosmic dust is deceiving us, making objects appear redder, and, therefore, older than they are. Or who knows, these giant points of light aren't even galaxies, but something even more bizarre. One idea is that they could be supermassive black holes growing very fast, covered by a cloud of gas that makes them look enormous and bright. But, as more data arrives to confirm the distances, this hypothesis seems less and less likely to explain all the findings. The problem of the abundance of giant galaxies in the early universe remains standing. The second hypothesis messes with the heart of our theory. What if galaxies simply grow much, much faster than we thought? The Standard Model assumes that transforming gas into stars is a somewhat slow process. But what if conditions in the primitive universe were different? Maybe star formation was more explosive. Another fascinating idea is that supermassive black holes, which sit at the center of galaxies, aren't a consequence, but rather the cause of their growth. Maybe seeds of giant black holes formed very early and functioned as gravity anchors, brutally accelerating the formation of galaxies around them. And the third hypothesis is the most radical of all. What if the rules of the game themselves were different back at the beginning? This line of thinking suggests that the problem isn't how galaxies form, but cosmology itself. Some scientists propose small changes to the Standard Model, like the existence of primordial dark energy. This energy, which would have only existed right after the Big Bang, could have created much denser regions of matter, which functioned as turbocharged cosmic cradles, giving an initial advantage to the formation of giant structures. If this is true, it would not only explain the galaxies, but change what we know about the ingredients and evolution of our universe. If you also freaked out about this cosmic mystery and want to know the next chapters of this universal detective story, subscribe here to the channel and turn on the notification bell. The James Webb discoveries are happening now in real time, and each new image could be the missing piece in this puzzle, or an even bigger enigma. So, what did NASA find at the edge of the universe? The answer, for now, isn't a certainty. It's an even bigger and more interesting question. James Webb didn't come to break cosmology, but to challenge it in a very exciting way. It showed us that the first galaxies weren't just babies, but also giants that grew too fast. Each new discovery, like that of the Jades galaxy, seen just 290 million years after the Big Bang, pushes the limits of what we thought was possible even further. The real revelation here isn't just the galaxies. It's us realizing that the origin story of the universe is much more complex, fast, and dramatic than we dreamed. The telescope didn't give us a period at the end of the story, but a totally new and electrifying beginning. It opened a door we thought we knew and came face to face with a horizon full of new mysteries. Science is this journey, and as the great Carl Sagan reminded us, the universe is not only stranger than we imagine, it's stranger than we can imagine. And thanks to tools like Webb, we're only beginning to read the first page.